All right, we're going to do the checkpoint. It's the third one. Looks like this. It has a person pulling this system of blocks up the incline. So we're going to generate an expression for the acceleration of the block using only the given variables. So let's get a good sketch of this. So it says the man pulls with a tension force that's given, a block of mass, capital M, and it's increasing speed, so it's V up and A up. And the hill itself is frictionless. So this surface is frictionless. Now, there is also another block on top, and that has mass little m. This is big M. And for little m, there is a friction force. So we'll call it friction force lowercase f. They're using f sub f, but I'm going to use this, between m and little m. Okay, so this is between ground and big M. And this mass has the same acceleration as this mass because they're moving together. Okay, it's not moving, it's just moving not the same speed as the bottom block. And this angle here is like that. So if I want the acceleration of this, I'm going to draw a free body diagram of big M. I've got tension, weight, there's no friction. That way I'm going to make my positive line of action up the incline. This is the normal force of the floor. Then we've got the normal force from the top block. And we've got a friction force that's holding this block up, right? That's pulling this down. So this is this little f from that M. Okay, so the other way you can do it is you can take these two blocks as a system, and we're going to be talking more about this shortly. So if I look at it as if the total mass, right, is both blocks together, I would then have the weight of both together. I would have tension is still external to this system here. There is this friction force, but now it's internal, right? We've got the normal force acting upward from the ground. So like, it might be easier for you to understand if you look at the bottom block, the top block and the bottom block. Oops, this is being held up that way, sorry. So what this block here experiences is pressure from, the normal force up from this bottom block, friction holding it in place, and its own weight. But if you include them both together, you've got this block and this force and this force, they're equal and opposite, it's internal, and you've got this force and this force, those are internal. So that's kind of a useful way to do it. You just also have to include, then you're pretty much done. You have a pretty simple system here if you take them both together, but you can do it either way. So this force I'm going to break into components. With the angle of the incline in here. So my equation looks like this. And I've got Ft minus Fgx equals max. So Ft is a given. This is the both masses together times g times sine of that incline angle equals both masses times acceleration. So the expression for acceleration looks like this. And listen, you can do this because they have the same acceleration. If this was slipping off, then it would be a problem. But because these two things have the same acceleration, you can actually solve for this together. So this this is called system solving, which we're going to get into a lot more. So how do you score yourself when you're doing this problem? This is a problem solving, right? This is this first one. And I would hope that you would have done definitely developing, like you drew some sort of labeled sketch. You were able to do a free body diagram, even if you didn't know to do it like this. And you generated your equation and solved for an answer, even if you made mistakes. So if you didn't think to do it together and you wrote out your equation like this, which you may have done since we haven't really done problems where we're solving for systems. You could have also generated an equation that looked like this. And since this friction here is given, this would be legitimate also. So you could have solved it using this as the system and gotten that. Or you could do it like this and gotten that. So either way would be correct. So look at what you have to do problem solving. I show givens and variables on a labeled sketch. I draw diagrams. You show the equations you used, the numbers you plugged in, and an answer. Well, the numbers you plugged in are these given values. So as long as you did that and you got an answer, it's fine. Now, if you did it and you did it correctly, that's advanced. Okay? Number 2, which graph shows the most accurate relationship between mass and acceleration for changing mass m undergoing a constant force? So since the second law says that net force equals mass times acceleration, acceleration is inversely proportional to mass when net force is constant. Therefore, graph C is correct. All right, so you want to state Newton's second law, and then you want to talk about the graph sheet, okay? Compare the tension of the rope acting on the bottom block to the tension of the rope on the person. So those are action-reaction force pairs. They're going to be equal. So when you draw the free body diagram of the block and you have tension this way, and you draw a free body diagram of the person, you'll have tension that way. So these two forces are going to be equal and opposite. And this is a statement of Newton's third law. So you want to state Newton's third law, you can draw diagrams, right? And then you want to say, therefore, Ft on the person is equal to the opposite sign of the tension from the box from the person on the box. Okay, so you want to show that overtly. If the person drops the rope, what happens? Focus only on the immediate time period following the release. So if you look at your free body diagram, and originally you have this rope and then that's gone, look at your equation here, right? This equation, I'm just going to rewrite it, Ft minus F minus mg sine theta equals m over m equals a. So what happens? If this goes to 0, then you're left with a negative numerator, and that means you're going to have a negative acceleration. So acceleration becomes negative. Therefore, the object begins to slow, to decrease speed, since velocity is this way and acceleration is this way, right? When v and a are opposite. Objects slow. Okay, so that's how you figure that out. So how do you score these? Well, this is these are, well, this one is graph interpretation. This is going to be Prose 7. So you can look over here and see, did you interpret the graph overtly using relevant features? That's you really can't do this. There's no mathematical model to really talk about. So it's mostly, you're going to be talking about this one. There is no graph creation problem here. The other two are explanations. So you're looking for, did I state the theory? Actually, there was a mathematical model. So if you talked about the mathematical model overtly, then that would be here, just so you know. And then here, if you stated the law overtly, right, and you backed it up with some evidence, then you're really talking about when making an explanation, I can correctly choose and overtly state relevant physics in the form of definitions, laws, mathematical models, equations, or relationships. So look at that holistically and see where you came out.